Hello everyone, welcome to Irfan CFPS. Today we are exploring firefighting pump room design. The contents for our today's session include what is fire pump room or fire pump shed or fire pump enclosure. Essential aspects of fire pump room. This category has been divided into two subcategories which reflects the main components and key considerations. Apart from that, we will check the pipe sizing and pump sizing as per NFPA 20 requirements. Finally, the most important part of our today's topic, fire pump room design. Here we are going to consider a particular layout and design the complete piping plan for the fire pump room. So let's start. Let's understand what a firefighting pump room is, or we can say what is fire pump room or fire pump shed or fire pump enclosure. Basically, a fire pump room houses the fire pumps and related equipment that deliver water to the fire protection system. The essential aspects of a fire pump room. When designing a fire pump room, we need to have knowledge on the key components, key considerations, pipe sizing and pump sizing. Apart from this, we need to consider several other factors in line with NFPA and local AHJ. Main components in a fire pump room. Basically, the main components typically includes fire pumps, controllers, jockey pumps, piping and valves. So we shall go through each and every detail in this particular section. Fire pumps increase water pressure, ensuring adequate flow and pressure required based on system demand. So we will try to understand this by looking at the picture on our screen. The electric pump comes with a motor, while the diesel pump includes an engine and exhaust. So if we use diesel fire pumps in our project, we also need a diesel tank to store the fuel. Basically, jockey pumps are specifically designed to keep the pressure in fire protection system within preset limits when there is no water flow. In short, we can say jockey pumps maintain system pressure, preventing unnecessary activation of main fire pumps. So this is the picture of jockey pump. They are also the main component in fire pump room. Basically, these controllers manage the operation of the fire pumps. Here, if you see on your screen, these controllers are a group of devices that are designed to control in a predetermined manner the starting and stopping of the fire pumps. Apart from that, these controllers monitor the status of the fire pump unit, and also they give signal about the condition of fire pump unit. You can see picture of fire pump controllers on your screen. The small one is for jockey pump and this big one is for electric. Basically, for diesel also you will have similar kind of controller. Valves. Basically, these piping and valves direct the flow of water through the system. Here you can find few pictures for piping and fittings, pressure gauges and also flexible connector which are installed in fire pump room. Here you can find OS and Y gate valves and also supervisory switch. We can call supervisory switch as tamper switch, which will be installed on OS and Y gate valve. From this supervisory, we will take connection to the fire alarm control panel, which indicates whether this gate valve is open or closed. So pressure relief valve and waste cone will be installed in relief line. This particular relief line will be considered whenever we have diesel engine fire pumps. We will discuss about this one in future slides. So check valve is also the most important component which will be installed on discharge side of the pumps. So test header hose valves. These are installed in test line. I will explain you when we discuss about the fire pump layout design in future slides. Flow meter. Flow meter can be either groove type as shown here on your screen, or they can comes with the flanged connection. So basically flow meters are also installed on test line. However, this will be used when we do the fire pump testing during testing and commissioning. So extinguishers to be installed in pump room, and fire department connection will be installed outside the pump room or outside the building. Considerations which has to be addressed before we proceed ahead. Protection. It is crucial in ensuring the reliability of firefighting systems. These enclosures safeguard the pumps from environmental factors such as dust, moisture, and extreme temperatures, which can adversely affect their performance. So proper protection must be required for this fire pump enclosure or pump room or pump shed. So this is the most important slide which we need to consider when we are choosing the pump enclosure. Basically, if the complete building is served by the automatic sprinkler system, then the fire pump must be at least 50 feet away from any fire exposures or fire hazards. Or else, if the fire pump is inside this particular building, it needs to have at least a 1 hour fire rating. And the second scenario would be you have a building which is not protected by the sprinkler system. However, you have hydrant network or any external fire hose cabinet network, or if the building is partially protected, then the fire pump needs to have at least 2 hour fire rating, or it must be at least 50 feet away from any fire hazards. If you have any queries related to this, you can just comment so that I will clearly explain in more detail. Pump enclosures must be pre-planned with fire department, or else they must be accessible directly or through a fire resistance corridor. Here we have mentioned a note. It is not acceptable to exclude sprinklers in pump enclosures that are located within fully sprinkler protected buildings. Sprinklers must be installed in these enclosures as well. So for example, your pump room is inside a particular building which is already having sprinkler system in the entire building. Thus this pump room also has to be protected with the sprinkler system. Requirements. They play a critical role in ensuring the proper operation and longevity of the fire pump systems. Some of the most important requirements to be considered as per NFPA 20 are heat, ventilation, drainage and lighting. These are the most important parameters or factors that has to be considered whenever we have or we are going to consider any fire pump room or fire pump enclosure. The fire pump room must be maintained at least 4 degrees centigrade. If you have diesel engine fire pump installed in the pump room, then the temperature to be maintained shall be cross-verified with the engine manufacturer. In warm climatic conditions, we need to cool the space or the pump room to stay below the controller manufacturer's recommended maximum operating temperatures. Basically, controllers have limitations, so we need to check with the manufacturer about the maximum operating temperature of the controller. Based on that, we need to cool the fire pump room. Where the diesel engine driven fire pumps are used and the temperature exceeds 25 degrees centigrade, we need to apply a derate factor to the engine horsepower. So provision shall be made for a ventilation of a pump enclosure, and ventilation calculations shall be done if required. Drainage is also an important requirement for a fire pump room. A flow drain must be installed in the fire pump room, and it must ensure there is adequate drainage and the floor shall be angled to direct water away from the critical equipments. The drain should be capable of handling any water discharge during normal operations. We need to consider special measures to drainage and flooding for fire pump installations below ground level. So these are the most important points to be considered whenever we are going to do the drainage for the fire pump room. Lighting is also the most important part of this pump enclosure. Artificial lighting shall be provided. As you can see here, tube lights are installed. Apart from that, emergency lighting shall be provided inside the fire pump enclosure. Emergency lighting should provide a minimum of 3 feet candles, 32.3 lux unless otherwise specified by authority having jurisdiction. Emergency lighting shall not be connected to an engine starting batteries. Emergency lighting shall be capable of maintaining the lighting level for at least 2 hours. So basically, we have covered the most important requirements such as heat, ventilation, drainage and lighting for pump enclosure. If you want to know how to select the fire pump pipe sizing, you need to watch my video on NFPA training series, which is already available on YouTube, where I explained as per NFPA 20 how we need to do the pipe sizing for the suction line, discharge line, test line and pressure relief line, etc. In order to know how to select the fire pumps, you need to watch my video Mastering Fire Pump Sizing, which is already available on my YouTube channel. In the fire pump room. First step, locate fire water tank and pump room in your project. This is the most important step. Second step, so upon identifying the fire pump room and water tank, and after selecting the fire pumps, here in this case I consider one diesel, one jockey and one electric fire pump. So after selecting the fire pumps based on the approved material submittal, we need to propose the location of these pumps inside the pump room. And next we need to propose the foundations based on the actual dimensions of the fire pumps. These dimensions of the fire pumps has to be taken from the manufacturer. So this is the most important point to be considered. Apart from that, these foundation details are necessary, and these details has to be given to the civil contractor so that they will start working at site. The height of the suction side of the fire pumps shall also be checked based on the approved material submittal. And third most important, the height of the suction puddle flange. This is the puddle flange which will be installed in the fire water tank. The invert level also has to be informed to the civil contractors so that they will make a provision for this puddle flange in the water tank. Third step, after identifying the pump room, water tank, foundations and the puddle flange height, next we shall design and draw the suction header and suction piping for all the pumps. On the suction side, we shall have gate valves installed for each pump. So here in the suction header also we have considered a gate valve for maintenance purpose. Please note, we need to avoid the fittings as possible as we can so that the frictional losses will be reduced and the pump can suck the water without any much frictional losses. Fourth step, in order to understand properly, I removed the suction line and I am just showing the discharge line. Basically, on discharge side of the pumps, we will have check valve. Then after check valve, we will install one OS and Y gate valve for each pump. As you can see on your screen, you have check valve and gate valve on discharge line of the diesel fire pump, and here also you can see for jockey pump these valves. Also for electric fire pump, we have shown check valve and gate valve on the discharge side of the fire pump. Please note, if the discharge side of the fire pump size is less, then we need to have a concentric increaser, and on the suction side, if the pipe size does not match with the suction side of the fire pump, we need to add eccentric reducer. So this you need to keep in mind. Also we can install flexible connectors on the suction and discharge side of the fire pumps. Apart from that, these two, or basically these three discharge lines are connected to a discharge header. Fifth step, so the discharge header shall be connected to the main fire water network line. Here it is connected to the automatic sprinkler system via main fire alarm check valve assembly. Sixth step, this is also a crucial step. If you have diesel fire pumps installed in your project, you need to have the pressure relief line which has to be taken before this check valve, and this line needs to be connected to the water tank or it needs to be drained. However, here in this particular drawing, we have taken the overpressure relief line from the discharge line before the alarm check valve assembly. Please note, this might not be accurate and as per NFPA 20 we need to consider the pressure relief line before this check valve. For electric fire pumps there is no need to consider this overpressure relief line. Seventh step. So test line shall be located on the layout drawing. This line will be connected or returned back to the tank. So provision shall be made on the water tank to pass this pipe. So here you can see test line will always have two gate valves. Here it is shown one gate valve and one gate valve here after the flow meter. There is a recommendation about the distance between the flow meter to these gate valves in NFPA 20. If you did not find in NFPA 20, then let me know. I will reply to you. Eighth step. Now we will club all these pipes in a single frame. As you can see on your screen, this is the fire pump room. Here there is a water tank. We have shown the puddle flange installed on the water tank, and we have shown the foundations along with the fire pumps for diesel, jockey and electric. Here you can see the suction header is connected to the suction line for each pump, and the discharge header with all these valves are connected to the discharge header, and this line is going to the main network through alarm check valve assembly. Here, as I already informed you, the overpressure relief line is going back to the tank or it can be drained, and this overpressure relief line will be installed basically before the check valve of this diesel engine fire pump. Here it is shown in the discharge header line. However, please note, for electric fire pump in general we will not use this overpressure relief line. Also we have shown the test header or test line from this discharge header connected or returned back to the tank. This test header is having two gate valves and flow meter. I missed one thing when I was explaining about the test line. The test hose valve headers can also be connected to this test line. I will explain you in future classes. Ninth step. See, in general we miss few things and don't care about the exhaust pipe size. These suction sizes and discharge sizes can be taken based on NFPA 20. However, the exhaust line sizing shall be determined based on D-rate factor calculations. This exhaust piping shall be directed to the outside of the building. And second point, the derating factor calculations can be done by using engine manufacturer's calculation sheet. 10th step. So after determining the exhaust pipe sizing based on derate factor calculations, position the diesel tank, size the piping with valves from diesel engine to the fuel tank accordingly. Please note, fuel piping shall not be galvanized steel or copper as per NFPA 20. However, we can use black steel pipe for diesel piping, and the fittings shall be steel or malleable iron fittings. The fuel return line shall be installed according to the engine manufacturer recommendations. Check valve can also be installed in fuel return line only if recommended by the engine manufacturer. However, we did not show any check valve here in fuel return line in this particular diagram. The calculations or the capacity of the diesel tanks calculation will be discussed in next part. 11th step, pressure sensing lines. Each pressure sensing line shall be taken after the check valve and connected separately to each controllers. You can just monitor the pointer here which I am showing on your screen. Since the sensing line here in this particular diagram is completely different, I will explain you that as well. However, please note once again, we need to consider the pressure sensing line after the check valve to each controller. For example, here you have jockey. After the check valve, you will take the pressure sensing line and you will connect to the jockey controller. For electric, you will take the pressure sensing line from the or after the check valve and you will connect it to the electric fire pump controller. However, here in this particular figure, it is taken from the discharge header and connected to the all the controllers and it is going to the floor drain. However, I don't know whether this mechanism is according to NFPA 20 or not. So 12th step. So cable routing shall be taken from each pump to the controller by using cables, and the cable tray also has to be shown. The sizing of the cable tray and the wiring selection will be discussed in next part. 13th step. This will be the final step of the fire pump room design. Here we will consider fire department connection line after the discharge header. Basically, FDC connection will have FDC fire department hose connections along with the non-return valve installed on the FDC line. This FDC will be installed outside the building or the fire pump room. If you are completely confused about the explanation, I will make the design in simplified format so that you will easily understand. I'll make this in a simplified way. Here you can see this is the water tank, for example, and puddle flange, and you can consider or assume this whole screen as the fire pump room. So just a minute, I will just draw the foundations for the diesel fire pump, jockey fire pump and electric fire pump. Fine. So here now what I will do, this will be the suction side of the diesel fire pump and this will be the suction side of the electric fire pump and this side will be the suction side of the jockey fire pump. So now I will just take some other color just to explain you. So from the puddle flange I will take the suction header and I will close this with blind flange, and from here we will take one branch and connect to the suction side of the fire pumps. So as I already told you, this will be the diesel, this will be electric and this will be jockey. So since for maintenance I will just put one gate valve here, and apart from that each suction line will have one gate valve installed for each fire pump. So suction chapter is closed. As I already told you, these pipe sizes will be calculated based on NFPA 20. I already uploaded a video on my YouTube channel about this. Now going back to the discharge side of the fire pumps, just we need to consider check valve and the gate valve on the discharge side. So for each pump you need to consider the check valve and also the gate valve. Here also I'll just maybe the symbol is not accurate for the check valve, however just for identification purpose I'm just putting this symbol. However basically this is the symbol for check valve I believe, and this will be gate valve installed on the discharge side of the fire pump. Now all these will be connected to the discharge header. I'm making it in a simplified way so that you can easily remember and understand. So from this discharge header we will take one line and this line will go to the main fire water network. Fine. And now coming back to the fire department connection, we will consider one line and it will go to the fire department connection. Okay, so fire department connection, and we will install one non-return valve in the FDC line. So now after that we will have a test line which will be taken from the discharge header and it will go or return to the tank. We will install two gate valves as already told you and one flow meter between these gate valves. There is a limitation or the distance to be considered between the flow meter and gate valves. You can just search in NFPA 20 and let me know what exactly is the distance to be maintained, and this you can mention in the comment section so that I will go through and I will confirm whether you are right or not. So test line also we have taken, and apart from that we will consider the overpressure relief line for this diesel tank. So I will just take some other color now, maybe red would be better I believe. Yeah, so we'll consider the overpressure relief line, and this one also will go to the tank, or we can drain this to some other location. So this can be returned to the tank. So you need to make provision if this line is taken to the tank. You need to make some sleeve in this water tank in order to connect this pipe to the tank. So overpressure relief line basically have pressure relief valve and waste cone. So now the chapter is closed about the piping. Now coming back to the exhaust line. So exhaust line, from the diesel engine exhaust we will take one pipe, and this pipe will go, or we'll take this pipe outside the building, and this pipe sizing will be calculated based on derating factor calculations from the engine manufacturer calculator or calculation sheet. And next, the pressure relief line. The pressure relief line will be taken from each discharge line after the check valve, and this will be connected to the controllers. Just I am explaining the concept, so please don't look at the design part. So here just see here. So here for example this is the diesel controller. So the pressure sensing line will be connected after the check valve and it will go to the diesel controller. Similarly, after the check valve we will take one more line from jockey and this will be connected to the jockey controller. From electric also we will consider pressure sensing line, and you will have check valve and drain valve and all those things. You need to refer NFPA 20 about the valve types which needs to be installed in the pressure sensing line. So this will be electric controller. Basically, this pressure sensing line will sense the variation in pressures, which will help to start the fire pumps. So here, for example, this will be the diesel controller, jockey controller and electric controller. So now what we have missed here, I believe everything has been covered in this particular figure. If anything is missed, let me know. However, I already covered in the previous slides about the missing portions. Since the video is lengthy, I will do these calculations as per NFPA 20 in our next part. Thanks for watching. If you like my videos, please comment and subscribe and share with others so that they could also benefit from my videos.